Next one is electric field at any point due to an electric dipole. Electric field at any point due to an electric dipole. How to find electric field at any point due to an electric dipole? That means, as of now, we have discussed two cases. One point is an axial line, and second derivation we have done for any point on equatorial line. And we have done for long dipole, and afterwards it was simplified for short dipole. But this is the situation is only applicable for short dipole. We cannot calculate for long dipole, just we are calculating for short dipole. In this situation, it's very simple. Here, dipole moment is a vector quantity, so that we are resolving the dipole moment into two components. Then we are considering this dipole is a combination of two electric dipoles, and we are finding the resultant electric field due to the both the dipoles at point P. Both the dipoles at point P. That means simple. Suppose this is P bar, which is acting along. This is P bar, which is acting along AB. That is from negative charge to positive charge P bar. And we need to find, we would like to find electric field at a point P, which is at a distance of R from the center of the dipole, which is from R from the center of the dipole. Then what I'm doing here, just to resolve the dipole into components. If I resolve, this is P cos theta. This is one dipole. That means I can write here as this is A1 and B1. A1, B1 is the dipole which is along the line joint. And another one, that means perpendicular to it. And if I resolve, A1, B1 and A2, B2 is the another dipole whose dipole moment is P sin theta. If you resolve, one dipole is P cos theta, another dipole is P sin theta. That means we are resolving the dipole moment P into two components. We have discussed in vectors last year resolution. That means P can be resolved in two components. One is P cos theta, another one is P sin theta. P cos theta is the electric dipole, and for that dipole, point P is on axial line. And for the another dipole A2, B2, the dipole moment is P sin theta. For this dipole, the point P is on equatorial line at a distance R from here. That's why I can write for the first one as E1 equal to, E1 bar is equal to 1 by 4 pi epsilon naught. For first dipole, it is axial line. That's why 2 into dipole moment is P cos theta into R will not come since it is a short dipole, divided by R cube. This is one. Now E2 bar, that is 1 by 4 pi epsilon naught P sin theta by R cube. Now we need to represent the values of E1 and E2. As you know that E1 is always acts along them. That's why this is the direction of E1 bar, negative charge to positive charge. Now here E2 bar is, this is negative, this is positive. Therefore positive charge to negative charge, this is the direction of E2. That means it is parallel to this one, P sin theta opposite. It is in the E1 bar is in the direction of P cos theta, and E2 bar is in the opposite direction of P sin theta. That means here E1 and E2 are perpendicular to each other. Here E1 and E2 are perpendicular to each other. Therefore, net electric field at point P equal to magnitude wise root of E1 square plus A2 square. In this one, both of them will have same values. 1 by 4 pi epsilon naught P by R cube is common out of the root I'm taking. That is 1 by 4 pi epsilon naught P by R cube is out of the root of what is left here, 2 cos theta whole square, and here left over is sin theta whole square. That gives as 1 by 4 pi epsilon naught P by R cube into root of 4 cos square theta plus sin square theta. Then I will write this one as 1 by 4 pi epsilon naught P by R cube into root of 3 cos square theta plus cos square theta plus sin square theta. I think all of you know it. Cos square theta is how plus sin square theta is how much? 1. That's why 1 by 4 pi epsilon naught into P by R cube into root of 3 cos square theta plus 1. This is the expression for net electric field intensity at any point on it. From this one, we can calculate equatorial and axial line also. Here we can say for axial line, what is the value of theta? 0 degrees. That's why we will get 2p by r cube. For equatorial line, what is the value of theta? 90 degrees. Cos 90 is 0. That's why we'll get p by r cube. We'll get the results from them also. Now, what is the resultant electric field at the point? That means the resultant electric field at this point will act in this direction, which makes some angle with E1 alpha. Therefore, how to find the value of alpha? Then I will use the space, small space. I can write tan alpha is equal to E2 by E1. Here, alpha is making with E1. That's why E2 by E1. As you know that E2 by E1 means 1 by 4 pi epsilon naught P by R cube is same in both of them. It will be cancelled. Sin theta by 2 cos theta. That's why tan alpha equal to half tan theta. Is it clear? Just note down carefully. Don't do the mistake. See, next concept is physical significance of dipoles. Heading is missing. Here it is called physical significance of dipoles. Physical significance of dipoles. What is physical significance of dipoles? As we know that here, whatever the theory is given, this is more than enough. In most of the molecules, if it will be related to chemistry almost. In most of the molecules, the center of positive charge and negative charge lie at the same place. That means there is no separation between positive charge and negative charge. Whenever positive charge and negative charge is not separated, the separation is zero. Therefore, electric dipole moment is zero. Suppose CO2, CH4 are this type of molecules. However, they develop a dipole moment. Suppose if you place in an electric field, what happens, sir, if you place an electric field? If it is placed in an electric field, the positive charge is attracted towards the negative charge, negative plate. That means otherwise the positive charge will move in the direction of electric field and negative charge will move in the opposite direction of electric field. As we know that positive charge will experience force in the direction of electric field and negative charge will experience force in the opposite direction of electric field. That's why positive charge will move in the direction of electric field and negative charge will move in the opposite direction of electric field. Then what happens? Obviously, the positive charge and negative charge can be separated. Whenever they separated, the positive charge and negative charge are separated, then it will develop some dipole moment. But in some molecules, what happens? The center of positive charge and negative charge will not coincide. Therefore, they have a permanent electric dipole. In CH4 and CO2, they are not having any dipole moment. After applying electric field, they will get dipole. But in some molecules, what happens? Already initially, they will have some permanent dipole moment even in the absence of electric field. Such molecules are called polar molecules, and water molecule and is the example for polar molecule. This is the significance of electric dipole, and it is important. And they will ask us some question like write the importance of